Hello and welcome to Ohm's Law Level 4. I did think that I wouldn't actually make any Level 4 videos. I would leave you to solve the more complex ones, but I'll just have a quick go at some of these to give you the idea of what a Level 4 question entails. Right, this is getting quite interesting now. We want to know what the voltage is across the voltmeter. And we note that this voltmeter is in parallel with this resistor here. In other words, this side of the voltmeter is connected to the same point in the circuit as this side of this resistor. They're both at plus 12 volts. This side of the voltmeter is connected to the same point as this side of the resistor. So that voltmeter is going to measure the voltage across that resistor. We also need to know the current flowing through that resistor to apply Ohm's law, and we do, because there's a current source here, 9.3 milliamps, which forces 9.3 milliamps to flow through this 1.2 millivolt voltage source, and it can't go up here because that's an ideal voltmeter. It never takes any current, so all of that 9.3 milliamps must go up here through this 102 milliohm resistor. So we know the resistance and we know the current. So we can apply Ohm's law. V equals I, R. And I is 9.3 milliamps. And the resistor is 102 milliohms. And that would give us the voltage across this resistor. But that's the voltage from this end of the resistor to that end of the resistor. The current is flowing through this way, upwards in this direction, which means this must be a higher potential than that. But the voltmeter is wired up the other way around. The voltmeter has its red dot, that's the positive dot, on this side, not on this side. So the voltmeter is, if you like, upside down. It's going to register a negative voltage. So the voltage that the voltmeter is actually going to read would be minus 9.3 times 102 milli, which is minus 9.3 e to the minus 3, because I can't use milli at this level, times 102 e to the minus 3. Great. That resistor is a red herring. This voltage source is a red herring. They make no difference to the answer at all. Just there to confuse you. I'll just do one more. Right. Here we're being asked what the ammeter would read. So we want to know how much current is flowing through this resistor, because all the current through this resistor must flow through this ammeter. How do you work out the current flowing through a resistor? Well, you need to know the voltage across it. Do we know the voltage across it? Yes, we do. An ammeter has a zero resistance, so the voltage on both sides of the ammeter will be the same. We know that this point here is 39 volts below ground. Below, because this voltage source has its positive side connected to ground and its negative side pointing up here. It's a 39 volt voltage source, which means this point here must be 39 volts below ground. This point here is minus 39 volts. If this point here is minus 39 volts and this point here is ground, then current is going to flow through this resistor that way, upwards, from the larger potential, in this case 0, to the smaller potential, in this case minus 39. So how much current would flow up through the resistor that way, which is the same way that the ammeter is measuring it? Well, that would just be 39 divided by 681. Great. That current source is a red herring. It makes no difference. That resistor is a red herring. It makes no difference. This, you don't really need to know that. It's just confirming that this point here is at minus 39 volts, but you could work that out anyway from looking at this voltage source. So you have to know, for doing these level 4 problems, which components you can ignore.